Hey everyone, in this video we're going to look at an example where we're asked to take a function that's got multiple trig expressions in it and turn it into the form that's a single general cosine function. So you can see we're given h of t is equal to sine of 2t minus cosine of 2t, and we're asked to write it in the form of some amplitude factor times cosine of 2t plus some phase shift delta. Now this is very similar to expressing something into a general sine function, which was the last video on my channel. I'll link that in the description below. And it follows a very similar process, and it's honestly just a different trig identity that you need to use in your work. And if you can understand the process of turning one of these functions into a single sine function, going to a cosine function shouldn't be that much of a stretch. So very similarly to the last one, we're gonna just substitute in a trig identity for that addition of two variables inside the cosine, and we know that that is going to be cosine of 2t times cosine of delta minus sine of 2t times sine of delta. And then we'll expand. So we have, and I'm just going to rearrange as well for clarity. So we've got a times cosine of delta times cosine of 2t minus a times sine of delta times sine of 2t. And now you can see the coefficients of both of our terms here. We can compare them to what we are asked to or what we're given for our initial expression. So cosine of 2t, the coefficient is -1 in the expression. And we're saying that we want it to be in the form of what we've just written and expanded. So we want that coefficient to be equal to a times cosine of delta. So a and delta are two unknowns. So we need one more equation. We can see here, well, a or minus a times sine of delta, well, that's the coefficient on sine of 2t. And in our initial expression, you can see that there's just a hidden 1 there. So we want the coefficient of 1 to be equal to -a times sine of delta. And now we've got two equations, equation number 1 and equation number 2. We've got two unknowns, and we can solve this to like a simple system of two equations, two unknowns. Similar to the last video, the way that we can solve for a, we can remove our delta term by squaring each equation and adding them together. So by doing that, we get -1 squared plus 1 squared is equal to a squared times cosine squared of delta plus, and this will be -a squared will just become a squared, and sine squared delta. Great. We can factor out the a squared, and we know that cosine squared delta plus sine squared delta is Pythagorean identity that will be equal to 1. On our left-hand side will also be, that's going to be equal to 2, 1 plus 1. And we can see that a will be plus or minus the square root of 2. So we get two different options for a, and that's totally fine. We can choose whichever a we want. We just need to interpret our result and choose the solve for the other variable, making sure that our math is correct. So let's select positive because positives usually tends to be easier. So let's select a to be equal to positive square root 2. That's totally fine. Now let's plug this into equation 1 and equation 2. Well, you'll see that from equation 1 we have -1 divided by square root of 2 is equal to cosine of delta. And I'll write here from equation 1. From equation 2, we have, we've got multiply both sides by -1, divide. We've got the, very similarly actually, we've got -1 over root 2 is equal to sine of delta. Okay, well, let's take a look at our cast rule, because we have two equations that need to be satisfied, right? But we need to make sure that we're following all of these rules of our trig functions here. So if we read out our cast rule, we can immediately tell it's not in the first quadrant because we see that cosine of delta is negative and sine of delta is negative. So we can also say, well, okay, sine of delta is not positive, it's negative, so it's not in this second quadrant. And lastly, we can tell that cosine of delta is also not positive, it's -1 over root 2. So we can eliminate this quadrant. Thus, we can tell that our delta is going to be in quadrant 3, which means that delta is going to be equal to, if this here is pi radians, right, from our positive x-axis, then we know that our angle is just going to be pi plus whatever this little, just write a little 5, and that 5 represents our primary trig, our primary angle that we can solve from equation 1 or equation 2. So, and I'll write here off to the side, delta would be equal to pi plus phi. Phi is just being whatever, you know, taking the positive, the angle that we solve for equation 1 or equation 2 in quadrant number 1. That represents phi. So let's look at this. We can solve equation 1 or equation 2 now to get that primary angle phi. So we can imagine our special triangle here, right? And I'll draw this kind of like we're in quadrant 1, right? If this is a right angle here, well, we know that this is a special triangle with pi over 4 radians here. This is side length 1, this is side length 1, and this would be, the hypotenuse would be square root 2. Great. And we can tell here cosine of this triangle, of this angle right here, pi over 4. We already wrote it as pi over 4, but we know that both opposite over hypotenuse and adjacent over hypotenuse will be 1 over square root of 2. Right? So equation 1 and equation 2 are satisfied with the angle of pi over 4. We just need to make sure that we have the signs correct by putting it into quadrant 3, right? And we've already seen this. We interpreted this already, so we know it's pi plus pi over 4, which means that our delta would be 5 pi over 4, right? And if all this is confusing, then, I mean, hopefully this is something that you can work out without a calculator. But if this is like very last minute, you could just plug in like the negative into your calculator and it should give you the right result anyways, like 5 pi over 4. But it's really key to understand why you're getting 5 pi over 4. You're not just getting pi over 4. So definitely review these fundamentals if this is very confusing. And now we just need to finish off the question, because right, we have our delta and we also selected our a to be positive root 2. And remember what we started off with, right? We're just asked to express this function in the form of a cos 2t plus delta. So we can end this finally. We can say, therefore, h of t would be square root of 2 times cosine of 2t plus 5 pi over 4. And that should load in a second. And there you have it. That's all there is to this question. Very similar to a single sine function.